So as we know, in yesterday's class, we discussed what is baking soda as well as uses of baking soda. Same way, bleaching powder and properties of bleaching powder. So now, let us finish the uses of bleaching powder and then we'll proceed with the next compound called as plaster of Paris. So let us come to the last compound which is prepared by the salt. What is the salt actually? Common salt as a raw material. So many compounds as we are discussing which is formed by sodium chloride or a common salt as a raw material, and this is the last compound which is formed by raw material sodium chloride as the raw material. Now, as I told you yesterday's class, bleaching of fabrics, I told you to see that bleached cloth and unbleached cloth. Have you seen the difference, everybody? I have sent you the group also. Tejaswini has forwarded. Yes or no, all of you? Yes.
Yes.
So, if it comes to the bleaching powder, so what is the formula of bleaching powder, everybody?
CaOC.
CaOCl2 means calcium oxychloride.
Calcium oxychloride.
Calcium oxychloride we used to call it as a bleaching powder. So if you want to produce, we have to take what? We have to take a dry calcium hydroxide. Over that, if I pass the chlorine gas, I will get what? Calcium oxychloride plus I will get water. So this is the production of or the chemical equation for formation of bleaching powder. And we studied, of course, this is we used to call as dry, what we used to call?
Dry slate.
Dry slate. Okay. And what is the properties and all as we already discussed. So now you can see here, bleaching of fabrics, that is the major importance of this bleaching powder. So bleaching of fabrics, as if you have noticed it, so the mainly who is the actually the chlorine gas, if you notice, which is present inside, it's a strong oxidizing agent. So because of strong oxidation or oxidizing agent, understand? So yesterday I have told you what will happen, guys. Because of strong oxidizing agent, it will do something. Yes, please. The bleaching action will take place. So let us discuss what do you mean by this bleaching. So as we know, when the colored substances react with this chlorine, that is only we used to call it as bleaching. The colored substances react with the chlorine, then what will happen? They will turn into colorless. That is what by oxidation reaction they will turn into colorless. That is only we used to call it as bleaching. So if you see here, yesterday as Tejaswini sent that picture, one is very bright in color, another one is turns into colorless. So mainly the bleaching of fabrics means this is what how it will be happening. So that is also will explain as it is one of the importance. So if you notice in our book also, so they have given the most important use of bleaching powder. If you see where it is, this is what bleaching of cotton, and linen in the textile industry, for bleaching wood pulp in paper factories, and for bleaching washed cloths in laundry. So these all the things you can see the main importance of bleaching powder. What do you mean by bleaching? That is what we'll discuss now. Okay, so bleaching of fabrics or bleaching of washed cloths or bleaching of wood pulp in paper factories, everywhere we are using a bleaching. So I will explain you what is bleaching, so just you understand. So as we all know, because of strong oxidizing agent, we can use it in a what? Strong. Who is the strong oxidizing agent? Everyone?
Chlorine.
Chlorine gas, which is present inside. That is what reverse reaction. If I start exposed to the atmosphere, we all knows that what will happen. If I even start exposed to the atmosphere, CaOCl2, so it will react with the carbon dioxide and it will form what, guys? It will form calcium carbonate plus it will release chlorine gas. Of course, the chlorine gas which is present inside is only actually a strong oxidizing agent. That is why we will use it for many chemical industries. And if I dissolve this one in water, that is what, to make the drinking water free from the germs. Means we already know chlorine gas, we already studied. We can use it as a what?
Disinfectant.
Understand? Because it will kill the disease causing bacteria, all what is present inside the water. It will help to clear that. That is what. Now, the main use is, this is what? Bleaching cotton and linen in the textile industries. So let us understand what is that. So bleaching of fabrics means, it's very simple. Because of oxidizing property, the colored substances turns into colorless when they oxidized by what, guys? When they oxidized by chlorine. Okay. So that is what is the meaning of bleaching. So let us see that how this process. So takes a required amount of bleaching powder in a given volume of water. So we have to take a certain beaker or a container which is having a certain amount of water, and it is, you have to take a required amount of bleaching powder which is already dipped inside, which is already dissolved in it. Now you have to take the cloth or the fabric in the solution. Just you have to put it inside. Let me take suppose for example, I'll take one shirt. Okay, so this is what the shirt I have. Now I dipped this shirt for a certain period of time. So sometime you just leave it, dip it and leave it inside. Now the bleaching powder react with this water to release the what gas? Water, it will react and it will release as what gas? All of you.
Chlorine.
Chlorine gas.
It releases the chlorine gas. Clear? Now this chlorine bleaches the fabrics. So what do you mean by bleaches? Let us understand. So if the amount of chlorine becomes too much excess, so more and more chlorine is releasing, it can be removed by using anti-chloral solution such as like sodium thiosulfate solutions and all. So that is what you have to also remember, that if excess chlorine is released, we can remove it by using anti-chloral solution, which we used to call as sodium thiosulfate. Okay, but when it is chlorine is releasing, so what will happen means, as we all know, chlorine is a strong oxidizing agent. So after soaking this fabric in this bleaching powder solution, so a certain period of time, this chlorine gas will go and will react with this color of the substances. And after a certain period of time, if you have taken that from that bleaching powder solution and you dip in the fresh water, you can see the bleaching action of chlorine will be taking place and the substance will be turns into colorless. Colorless in the sense of almost the color will be shaded and it will be turns into colorless. So this turning of colorless because of oxidation property of what? Chlorine is only called as, what is to called, guys? Who is to called as bleaching.
Bleaching.
Understanding? So mainly we will use it in industries for production of cloths. So you can see that if you want to make it into decolorize or colorless, then we will soak in this bleaching powder solution. So because of oxidizing nature of chlorine, it will react with that, and that chlorine gas will react with the color of the substances and it will break the colors, everything. And after that, if you dip into the fresh water, you can see that the entire color will be dissolved, like removed from the cloth, and the cloth will turns into what? Everybody? Cloth will turns into colorless. So that is only ways to called as bleaching actually. So why this bleaching is taking place? Because of only one reason. Because chlorine is a what? Due to its oxidizing nature. Understanding? Oxidizing nature only this is taking place. So that is why bleaching of paper and cotton as well as linen in the textile industries, everywhere we will use this one. Okay. And laundry also. Bleaching like factories and for bleaching washed cloths in laundry, everywhere people will use this bleaching powder. Next, as I told you, you can see oxidizing agent in many chemical industries. So, for example, if you have taken as substances or the compounds which are the sources of chlorine. So we all people will use this one as an oxidizing agent. Like you might be to prepare a different kind of inorganic or organic compounds, or inorganic or organic compounds, whatever it is. So we people will use chlorine as raw material for that. Even if you want to prepare, for example, chloroform. So if you have taken the chloroform, you can see what is the formula of chloroform? CH3. So to manufacture, that is what it is used to manufacture of chloroform, we will use the chlorine gas. Understanding? So we will use a bleaching powder. So like that, we all can make it so many things. Many chemical industries they will use this one. Okay, drinking water for disinfecting water supply, making the water free from the germs. Everywhere we people will use this one only. Is it okay, everybody? All of you? Yes. So understand, Amma? Because of only one reason. Because as bleaching powder contains the chlorine, chlorine is the strong oxidizing agent, so that bleaching powder is also strong oxidizing agent. So this is what about all the salts which are prepared by the sodium chloride is the raw material. So first salt is sodium hydroxide, second one is bleaching powder, third one is baking soda. Baking soda, if you add the edible acid, it will turns into what? Baking soda, if you add the edible acid, it will turns into what? All of you.
Baking powder.
Understanding? Baking powder. Next one is washing soda, and that's all. These are the salts which are prepared by sodium chloride is a raw material. Next, let it be water of crystallization. I told you to read it, but anyhow we'll discuss that. Now we are going to study plaster of Paris. This is the most important one in entire chapter. Many times, many years, they will ask this question. Okay. So all of you keep reading plaster of Paris. Let us discuss what is this and how to produce, and everything will make it. So keep reading plaster of Paris. But this is not a compound which is prepared from where? Sodium chloride. Understand, everybody? Yes, please. Plaster of Paris. Plaster of Paris is not a compound coming from sodium chloride. Do you all understand? So it is entirely different one. So plaster of Paris basically we used to call it as chemical name. Basically we can represent with a POP. Plaster of Paris, POP. You might be name it. Okay. So now plaster of Paris is actually calcium sulfate hemihydrate. What is the scientific name, everyone? Repeat it. Calcium hydrate, calcium sulfate,
Hemihydrate.
hemihydrate is the formula. Okay, or you can say calcium sulfate half hydrate, whatever it is, half hydrate. So both are same. Okay, so now if you have noticed it here, these plaster of Paris, basically the formula of plaster of Paris, if you have noticed it, as according to the name calcium sulfate. What is the calcium sulfate formula, everybody?
CaSO4.
Hemihydrate or half hydrate. Half hydrate means 1/2 H2O.
1/2 H2.
Yeah, that is the formula of plaster of Paris. Each and everyone should knows that. Okay. Now, the name plaster of Paris came from the fact actually the first of all made by actually it is found in Paris. First time they obtained this plaster of Paris by heating gypsum. By heating what, Amma? By heating
Gypsum.
gypsum. So who is the raw material for production of plaster of Paris? All of you? Gypsum.
Gypsum.
Understand? Gypsum mainly found in Paris. That is why it is called as, what is to call? Plaster of Paris.
Plaster of
Yes. So plaster of Paris, basically nowadays we will use in massive ways. Like you can see many shops here and there everywhere for decoration, including the houses and all. Decoration and all, we are using plaster of Paris. Yes or no, guys? Different models and all, you can see that. Yes or no? All of you? So construction industry, we're having many use. You can see in our home also, if it is a newly constructed home, for designing and all, they used to use that one. You can verify it. Okay, everyone? Have you all seen that? Models, plaster of Paris models? I will show you, no issue. So many construction industries, we will use it. And many, we are having so many uses. Even in our hospitals also they will use. We will discuss that and all. So plaster of Paris, commonly we can call P dot O dot P. POP. POP means plaster of Paris. Okay. So what is the formula of plaster of Paris, everyone? CaSO4 dot half H2O. Read it. Reading is very important. CaSO4 dot half H2O is called as plaster of Paris. Is it clear, all of you? So what is the name of the plaster of Paris? Calcium sulfate hemihydrate. Clear? So let us discuss preparation of plaster of Paris. So for preparation, I will give you two equations. So whatever you are convenient, you can learn. Okay. So keep heading plaster of Paris. Plaster of Paris. Now, if you have noticed it here, basically plaster of Paris is prepared by heating the gypsum. So by heating the gypsum to a temperature of 373 Kelvin, by a temperature of 373 Kelvin or 100 degrees Celsius in a container which we used to like industrial container, the container which we used to called as kiln. What is the name of the container? Kiln. Kiln is the instrumental setup which we will use to produce the what, guys? Which we used to produce the
Plaster of
plaster
Paris.
of Paris. Okay. So by heating the gypsum formula is CaSO4 dot 2H2O. What is the formula of gypsum, everyone? All of you? CaSO4 dot 2H2O. If I started heating, all of you remember heat to up to what? Heat to
373
100 degrees Celsius, or we can say how many kelvins? 100 degrees Celsius is equals to how many kelvins?
373 Kelvin.
Kelvin. Okay. So you can heat either 100 degrees Celsius, heat to 100 degrees Celsius at 370 Kelvin, so that we will get the CaSO4 dot half H2O plus you'll get 1 by 2 H2O. Okay, 1 by 2 means we can write 3 by 2 H2O also. So 3 by 2 plus 1 by 2, again it will turns into 2. Am I right or wrong, everyone? 3 by 2 plus 1 by 2, which is equals to 4 by 2. 4 by 2 means in the sense of again 2. Am I right or wrong, everybody? Yes. So that is the process or production of plaster of Paris. So plaster of Paris equation is the most important equation which you all need to learn it. Clear? So write it. So CaSO4 dot 2H2O. If you're heating to what temperature? Everybody, heating to what temperature? Yes, 373 Kelvin. Then it will loses water molecules and becomes hemihydrate. What do you mean by hemihydrate? Hemihydrate also we can call as half hydrate. Understanding? Half hydrate. That is only called as plaster of Paris. What is to call, everyone? What is to called as plaster of? Clear? Now, note, you have to remember very carefully, half of a water molecule is shown to be attached as a water of crystallization. And you remember the plaster of Paris formula, as which is given, only half of water molecule is present. Understand? So, if it is not possible to have half a water molecule, then you can see, you can modify the formula like different way, like balancing equation. Sir, I'm difficult to remember this half and all. I can balance it in another way. You can see how to balance it. So CaSO4 dot 2H2O. So I will take 2 molecules of this one, 2 moles of gypsum, 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 so that you can see heat to what temperature, everybody? You should not heat more, you should not heat less. Heat to only what temperature, everybody?
100
370
degrees.
degrees. Okay. You should not heat more than this and you should not heat less than this. That is why heat to. Mr. Noor, mute yourself. Heat to 373 Kelvin. Understand, everyone? It should not be crossed more than that. It should not be less than that also. Okay. So heat to 373 Kelvin. Then observe very carefully here. I will take one CaSO4 molecule. It is taking how many water molecules, guys? It contains how many water molecules? All of you. Half water molecule. Am I right or wrong? Half water molecule. Now, I will take one more CaSO4. Then it will also contains how many water molecules, everybody?
Half water molecule.
So, means in the sense of, can I write it as a 2 CaSO4 half plus half, which is equals to 1. Am I right, Mr. Everyone? Others understand or not?
Yes.
Yes. See, one CaSO4 is sharing half water molecule. I am taking 2 CaSO4 molecules so that it will share, both together will share 1 water molecule. Is it okay, guys? Yes, please.
Yes, sir.
Because practically this is not possible. No water molecule will be shared half. That is why the formula of plaster of Paris can also be written. How we can write? What is another formula of plaster of Paris? 2 CaSO4 dot.
Plus H2.
Okay. See, this is formula. First formula will says that one molecule of CaSO4 is sharing how many water molecules? Everybody. Half water.
Half water.
And if I write this one, 2 CaSO4 dot H2O, what do you mean by this? 2 CaSO4 molecules is sharing how many water molecules? Is sharing
One water.
one water molecule. That is why you can write, this is also the equation of plaster of Paris. Anybody having any doubt, you can ask. Is it okay, guys? All of you? Yes. 2 units of CaSO4 sharing how many water molecules? One water.
One water molecule.
One water molecule. That is what you have to remember. Is it okay, all of you? Yes, please.
Yes, sir.
This is only the
Yes, sir.
preparation of plaster of Paris. Now, let us discuss what is the properties of plaster of Paris and what is the uses of plaster of Paris, as it is very, very important. So, what is the formula of plaster of Paris, everyone?
Calcium sulfate.
Calcium sulfate,
Hemihydrate.
CaSO4 dot half H2O.
Half H2O.
Or 2 CaSO4 H2O. Okay. So properties of plaster of Paris. Write it. Now, do you all notice in our surroundings bone breaking people, like leg is damaged, hand is damaged, hand fracture, bone fracture and all? They will come with one bandage with the white color powder is stick to that. Have you noticed it, everyone?
Yes, sir.
Yes, sir.
All of you? Yes, please.
Yes, sir.
Yes. So actually, that white color one, which they will be used to stick the bones properly by tying the bandage, that is actually the white cast. That is what we used to call plaster of Paris. So the properties of plaster of Paris, if you have taken first one, plaster of Paris is a white color powder. Plaster of Paris is a what powder? It is a white powder. Okay. Next one. So it contains half water molecules. One molecule of CaSO4 or 1 unit of CaSO4 will share how much water molecules, everyone? Half water.
Half water.
Understanding? So this is only present inside, but it is not. Because of this, it should not looks like a wet in color. It is completely dry in state. So we all know what is the importance of this one. That is only we used to call something. Amount of water present. What we used to call? Water of
Crystallization.
water of crystallization. Of course, we'll discuss that one. Okay. Second one. Plaster of Paris has a very remarkable property of, write it, remarkable property of setting into a hard mass on wetting with the water. So that is why you can notice it. If you are constructing the new home or something, you ask your parents, they will never keep the plaster of Paris exposed to the atmosphere or never keep it left it by reacting with the water. Because if you dissolve this one in water, just if you add the plaster of Paris to the water, it will become very hard just within an hour, half an hour time period. It will turns into powder, it will turns into very, very hard. That is the reason the setting of plaster of Paris is actually due to the hydration to form crystals of gypsum, which is to form a back, like reverse reaction will takes place. So that is the reason plaster of Paris cannot be stored or exposed to the atmosphere or water. Sir, if I expose to the water, again it will turns into hard mass. Sir, what will happen means, so CaSO4 dot half H2O will be reversed. It will react with again water or moisture and it will form again back. What it will form? Everybody, it will form the gypsum. Okay. So this gypsum only we used to call, what we used to call? Hard mass. Understanding? So it will set as hard mass. So that is why you can see the setting of plaster of Paris is actually, you can notice it, even it will be slightly expansion in volume also. That is why we basically will use this one in making cast. Do all people know cast means? Cast in the sense of like making statues, toys and all, we will use the castings. Like when I got toys, when I got statues and all, we'll use the casting. Do all people know or not? All of you?
Yes, sir.
Yes?
Yes, sir.
Yeah, nothing will be there. The shape will be, outer shape will be present and they'll put inside the clay and they'll remove it. Have you noticed it or not? All of you? Please respond, Ra. So that is what it is. So the setting of plaster of Paris is actually slightly expansion in volume. Because of that reason, we are using in making the cast for statues and as well as toys and etc. etc. So because of this property, setting into a hard mass, we always need to preserve in a air container, like airtight containers. Otherwise, it will become useless. Okay. Now, let us see in our daily home. You can all experience it. This plaster of Paris. Yeah, I think your chemistry holiday homework is making a plaster POP model. Am I right, everybody? Umar is saying.
Yes.
sir.
Yeah, you all can experience it that. So now I will show you the POP things. If you go to any hotels nowadays, you can check it for decoration. Even in our houses also, POP decorations are many models, because this is the one which we will use POP designs. You can see that. So everywhere you can be making that. Have you noticed it in our roof? It will be seen like this. Have you checked it, everyone? All of you? Yes, please. Have you seen that
Yes, sir.
roof? Yeah,
Yes, sir.
we make it. These all are POP models only. So POP only, if you mix it with water and if you design the shape, within a half an hour, it will turns into what? It will turns into hard enough. Clear, Amma? So that is the reason we will make this one. So I will show you next. POP cast. Those who don't know cast, you can see that one. So POP, oh, it is coming up like plaster of Paris cast. So we'll discuss. Now understand what is plaster of Paris, everybody? All of you?
Yes, sir.
Yeah, plaster of Paris cast for making the dolls and all, dolls, ideals, god images and all. So actually this is also a cast. You can see that broken bone being set by using plaster of Paris. Have you checked it, everybody? All of you? So what will happen? Suppose the leg is broken here, they will tie the bandage and they are applying here. Have you checked it? The plaster of Paris? They will mix with the water and they will apply on the surface, so that what will happen? It will become very, very hard. Toughly it will pack that bone, so that the bone will attach very easily. And after 2-3 days, 4 days, 5 days, you can see that the cloth automatically it will become little bit loose. Why it will become loose, everybody?
It is exposed to air, sir.
Because as it is, no, it will, that slightly expansion in volume will take place. Understand, Hari? That is the reason. That is even the property we people are preferred to use in cast for we can see that statues. Let us discuss. So you can see that for making this and all. Have you noticed it here? This is what we used to call as cast. So per POP model. So you might be notice hands models and all, they are making like this. This is only we used to call as cast. So inside that, okay, here not it is coming properly. Actually, we will pour it and we will make it Ganesh ideals and all, you might be notice it. So this is the reason, basically, this is only we can say cast for making the statues and as well as toys and all. We people will use this POP. You can see here, the doctor is